चेक कर लूंगा।
बना दिया आपको होस्ट।
लाइव हो गया।
लाइव हो गया।
ओके।
हो गया लाइव।
ओके ओके। So, hello everyone. So in today's session, we will try to make a ML model and try to learn AI on edge at the in on the IndusBoard. So this is a IndusBoard, very small device, as you can see here. As you can see here, this is the IndusBoard. In the second screen, you can see here in the camera, the second screen, this one. Hope this screen is visible. So this is the IndusBoard coin, and that has the ESP32 chip on it, and it has inbuilt many sensors. So currently it is running the AI model on the edge. So it is not connected to any internet or any cloud. It's running at the edge, and it is detecting. You can see its prediction output here in the second screen on Arduino ID, a serial monitor. Its predictions. So this the AI model is running on this, and it is predicting what is my next move, and what is my next gesture. It's predicting out and telling the result up, right, or left. So as I can, let me clear it out. And when I move this board towards up, see it, the prediction towards the up will increase 82%. When I move the boards towards the right, the prediction towards the right get increased. See 93%, 90% or 74%. When I move it toward the left, its prediction towards right and up both got decreased. So it is predicting my next gesture. It is predicting my next gesture. Like here you can see, I am moving it. I am moving it, and it is predicting in the real time. So the AI model that is running here for the prediction of the gesture is on the edge. It is running on the edge. It is directly running on this board without need of any Wi-Fi or any connectivity to the cloud. So how to do it? So as you can see here, I have used this code, the edge impulse code. So to make this edge impulse code, to make this AI model like this for the gesture prediction, you can make many other different kind of AI model and run at the edge on the device, like digital tune IoT, where it can predict the temperature, or you can predict the vibration, or classify the different segment using the classification AI model. So all these thing model can be run on the edge on the Indus board itself. So let's see how we can make a AI model, and how we can deploy the AI model to run out at the edge on this Indus board coin without needing any Wi-Fi connectivity, or without any need of or cloud connectivity. It's totally run on the edge. So suppose that if you want to make a gesture-based mouse, or you might have seen the a smart watch that when you move this hand, it will automatically detect, and it will turn off the screen. And when you move hand like this, then so all these are the AI model based on the AI model. In similar way, you can also
वो
make the
प्रमोट
AI.
करना, लिंक शेयर किया मैंने। हाँ।
Yeah, similar way you can make this kind of model for predicting the forest fire, and many different kind of such AI things. So today we are going to make such device, and we will see how we can make your own AI model and deploy it and run that AI models on the edge, using the edge impulse. So the tools we are using is the edge impulse, and it can be used for your day to day, for your experiment person, or also it can be used for the enterprises level. Like if you are actually going to deploy some kind of AI ML model, some or device like this at this IndusBoard coin to some factory or some somewhere, then it can be used for the enterprises level as well. So it supports the both of the things. So it can this age impulse is actually the things that is being used by many factories and many companies to for that. So here we are not using for the experimental purpose as well. It can be also be deployed in the actual life. It's a actual IoT, AI IoT that being actually being used in the industry. It's an industrial IoT. It's being actually being used by the many companies. To make any kind of AI ML model, you need a data set. So first what you need to do is to install the Edge Impulse on your PC or laptop. So depending on the OS that you are using, either MacBook or Windows OS, you can install the Edge Impulse or and Edge Impulse data forwarder. This thing, because we using Edge Impulse data forwarder, it helps us to connect our board or devices to the Edge Impulse, and so that we can forward that AI data, so that we can forward the sensor data to train the ML model. So after installing the Edge Impulse data forwarder, we need a code so that it can forward the data. So this data can be anything like accelerometer data, sound sensor data, voice data, or it can be the gyro sensor data, it can be temperature sensor data, it can be the lux sensor data, or any other sensor data, air quality sensor data, temperature data, humidity data, any kind of data. So here in this Indus board that currently we're seeing here in the screen, has the accelerometer, magnetometer, temperature sensor, sensor, and light sensor, all those kind of things. So we can make any kind of ML model and deploy it using those sensor and deploy it on the device. So let's make a project like AI gesture prediction that can predict the gesture. It's up gesture, right gesture, left gesture in the mouse. When I do this, move this board, it can predict the gesture. It's up, left, right, using the AI model running on the edge. So let's make that model here. So I am going to so for that we can either use the accelerometer or the combination of accelerometer and magnetometer both. So here the sensor that have used accelerometer sensor and gyro and the magnetometer sensor is from ST Microtronics, that is LSM303. So here we, after installing the Edge Impulse data forwarder to our PC, you can install the Edge Impulse data forwarder using the command that is provided by the Edge Impulse. You can see that installation process here, how to install Edge Impulse data forwarder. So first you need to npm install Edge Impulse CLI, and after running this command, you just need to copy this command on the terminal here. Open the terminal. Whatever, if you are using the Windows, then you can use the CMD. If you are using the Mac OS, then you can use the terminal of the Mac OS and paste this command and execute it to install the Edge Impulse CLI. Or if you're using the Ubuntu, you can use the same thing, because the both use the same command, the terminal, the Mac OS and the Ubuntu or any other Linux device. So after installing the Edge Impulse CLI, you need to install the what say this one. You need to also install the uh, Edge Impulse data forwarder. So after installing the Edge Impulse data forwarder and Edge Impulse CLI, your device is ready to get to use the Edge Impulse. So after that, you need to sign in into the Edge Impulse Edge Impulse account. It will give you the two option. It's the enterprise level. So if you are actually going to deploy some kind of AI ML model or AI ML device that is made on that is running on this IndusBoard coin, then you can use the enterprise level. Otherwise, you can use the free version. So here I am doing the experiment and I am telling you how to do it. So I am using the free version. So all of you can choose the free version. So you can make any project, support the gesture detection. So I have already made the gesture detection project here. So I am selecting that. After signing in, you need to do that. Okay, so after installing the after signing in and creating the new project for the gesture detection or whatever the ML AI ML project that you want to deploy or make on the IndusBoard coin, after making that project, then you need to go to the age impulse data forwarder thing, and then to forward the sensor data, whatever the sensor that you are going to feed, like accelerometer, magnetometer, or any other sensor that you connect with on the IndusBoard. Here IndusBoard Quant support, I already have, I've told you that it has the touch sensor, temperature sensor, magnetometer sensor, accelerometer sensor, all those sensor are, and the light sensor. So I can use all these inbuilt sensor to make any kind of ML model, like light detection or light prediction or forest fire prediction, any kind of projects. For example, I am using here, I am making here the gesture prediction or just AIML model. So I have told you I am using LSM 303. So you need to make a age impulse data forwarder code so that it can forward this device, this IndusBoard connect with the age impulse and forward the data using the USB that is connected here. As you can see here is my laptop and it is connected to the USB, and this IndusBoard connected to USB. So it's forwarded data using the USB to the Edge Impulse website. So for that, we need the Edge Impulse data forwarder code. So if you check their website, they will already give you the accelerometer Edge Impulse data forwarder code. So what we will do, we will modify this code according to us. So whatever the sensor data that we want to forward it. So here I have here is the data forwarder code. So this is the data forwarder code that we need to upload to forward the data to the Edge Impulse and to connect my this IndusBoard coin or to the Edge Impulse. So I have modified the base code example that is already given. You can modify this base code that is given, the example code that is given by the Edge Impulse to forward the data. So you can modify according to you and you can modify according to your sensor. So here I am using the LSM 303 sensor. So I've used the LSM 30 ACC sensor in the code here to forward the ACC data, accelerometer data. If you are using the light sensor, then you can change it with the analog sensor or light sensor. Or if you're using the any other health sensor or any kind of other sensor, you can change the code, modify the code accordingly. So this is the data forwarder code. Here I have used the accelerometer sensor and included that thing in the code for the data forwarder code. So this is just to forward the data, and after that we will initialize the communication with the sensor and all those things. Here is the frequency that you want to transmit the data to the Edge Impulse. So you can change it according to your here at the 50. Here I've set the frequency to the 50 hertz so that it can transmit the data at this frequency and this interval of time, and this 1000 millisecond interval of time. So here we can separate the in accelerometer. This is 3D accelerometer. So it's X, Y, Z. It's three dimensional data. So it's give you X, Y, Z axis, three different values. So I separated each value using this serial dot println, this will separate the different value in three different values. So when I upload this code now, after that, what I will do, I will connect this is our Edge Impulse data forwarder for the accelerometer code that will going to forward the accelerometer data on this IndusBoard coin, on this IndusBoard coin. So this IndusBoard coin is connected to the USB now, and I am uploading this Edge Impulse data forwarder code to the IndusBoard coin. So here I have selected the ESP32S2 as a DEM module as a chip, because this is a chip that is used in this IndusBoard coin. And then in tools we have enabled the CDC, because it need to be enabled. Always keep this enabled when you are using the IndusBoard coin. And after that I am going to upload it. After that I am going to upload it. Okay. So what it will do, it when it upload, now it will take the sensor data on the from or that is inbuilt sensor data that is present on this IndusBoard coin, and this sensor data being transmitted using the USB to the Edge Impulse in the real time, and then our this IndusBoard get connected with the Edge Impulse. Okay. So after uploading this code, what I will do, I will simply open the Edge Impulse data forwarder on the command line. So the code is uploading. So let me close this serial monitor for now. So the code is uploading here on this IndusBoard coin, on this IndusBoard coin. So on this IndusBoard coin, now code is uploaded. Now when I open the serial monitor here, I can see the XYZ data of the accelerometer. Okay. So what I need to do first, I need to close this serial monitor because it makes conflict with the with the data forwarder that we are going to run on the CLI. So now I disconnect this board here and reconnect it and ensure all the serial monitor are closed everywhere. All serial monitors are closed. Okay. Now I open the terminal. This is my terminal and this is my IndusBoard coin. Okay. So here is my terminal and here is the IndusBoard coin. I am replugging the IndusBoard coin in the different port. Now our IndusBoard coin is connected here. Here you can see on the laptop. Now what I will do in the CLI, I will open the edge impulse data forwarder. So for that, I need to run this command. 1 minute. What is the command? Yeah, this command, edge impulse data forwarder. Okay. So if you are new, when you run this command, it will ask you to log into the edge impulse account where you need to enter the email ID and then password, and then you need to connect with that particular project. Okay, so let's use it. Let's for your sake of convenience, let's use it as a clean. Okay, so if you want to run that as a new, then I can use this code, edge impulse data forwarder clean, and run this code in the CLI. So if you are using the Ubuntu, you can use the Linux terminal. If you are using the Windows, then you can use the command CMD command format. And if you are using the Mac OS like me, then you can use the Mac OS terminal. And this syntax remains the same for all these OS. So when I hit enter, as you can see, it will ask me what is the email ID. So my email ID is so now it's connected. So it's connected to the edge impulse, as you can see, and it will give me all the list of project that I have in my account. So whatever the project that you have just created for training the ML model, you need to connect with that project. So here is the my project Aswini gesture. If I'm meeting any other fault prediction using the accelerometer data, then I can use the fault prediction, whatever the project that we have made. So here I am using connecting it with the Aswini gesture project. So when I hit enter, it will connect to that. Now, now this thing is connected, as you can see. This IndusBoard coin is connected. This IndusBoard coin is connected with the PC, and it get detected. And here in the terminal, and it is asking, there are 3 values that is coming from this board sensor. So what is this value and what you want to call and how do you want to separate it? So here my value is XYZ axis of the accelerometer. So I separate X y z with the comma, and this is how my 3 value get separated. Okay, so here I will write X comma y comma z. So all these value got separated. Where I hit enter, it get connected, and it give me a URL to train the model. So I can simply copy this URL and go to the to train model, or you can also, what you can do, you can go to the edge impulse on that project. When you see in the devices here, I can see, you can see the devices here. So when I click on these devices, you can see the IndusBoard is connected and acquiring the data, sensor data, 3 axis X by Z. So my IndusBoard coin here, my IndusBoard coin got connected here. So here you can see. So sorry for that. Yeah, let me make it half. So here my IndusBoard coin, this IndusBoard coin got connected to the edge impulse. Here is so connecting her green button. So now my device is connected with the edge impulse to collect the data. Okay. So let me put it here. Okay. So now our edge impulse is connected with the IndusBoard coin, and it is giving the data to the edge impulse. Okay. In the devices, you can see it's connected XYZ here. Okay. If I want to delete this device, then I can delete it. Then I need to reconnect it. Okay. So now I go back. So in the devices we have already tested out, and then go to the data acquisition thing. Go to the data acquisition option. So now here we need to acquire the data. So suppose that I want to detect the gesture, up gesture, left gesture, right gesture. So I simply what I will do here I will select the device, that is the IndusBoard that is already connected, will show it in the list, and then label it. Suppose that this is the right gesture, I want to train the right gesture, so I write it right, and then the sensor that we need to connect. And then when I click on the start sampling, I just need to, after clicking on start sampling, I simply need to move it to the right gesture to train the model data. So it will take the sample of all the right gestures that I am doing right now. Here in the camera you can see. Here in the camera you can see. Here in the camera you can see. So it has taken the right gesture, and here is the accelerometer data. So then I will take one more sample again for the right gesture. Click on start sampling and then start moving to the right. So now I got one more data regarding the right gesture. You can see the XYZ axis graph of the sensor of this IndusBoard coin. So suppose that I want to now make a up gesture. I want to train the up gesture data. So I simply label it up and then click on start sampling, and I can move this board. Towards the up. Okay. I can move this IndusBoard coin towards the up. 1 minute. Let me start the camera. Yeah, I can move the sensor towards up. So here I didn't move that much. So let's delete this data and restart, resample it. So in this way you need to collect the data for all the gesture, all gesture sensor. Here I am moving the up and it is sampling the data. Moving the gesture towards up. So this is the up gesture data you can see. So this IndusBoard is connected to the edge impulse, and ahead we need to collect the data for different gesture that I want to detect using the ML model, and we need to collect the data around 10 to 20 data. The more the data, the more it will be accurate. So I have already collected earlier the data of up gesture, right gesture, left gesture here. Okay. And then after collecting the data, and then we need to define the data between the test data and train data. So you can split the data between test data and train data. So after collecting the data from this IndusBoard coin, from this IndusBoard coin, you need to go to the experiment. Go to the experiment now. So here what you need to do after that. Well, let me zoom it out. Yeah. So after that, what you need to do in experiment, you need to create the impulse. Okay. Create the impulse. And then you need to add the processing block. So here there are different options you will get. So if you are using any kind of color or any kind of voice thing, then you can use the recognizing the voice. Then you can use the spectrogram. This is used for the voice recognition and all those those kind of things. Here is a spectral analysis for detecting the continuous motion from the accelerometer. If you are using the accelerometer, then you can use it. Here is the flatten. If it is the single value like the AQI, air quality sensor, or if you using the light sensor or temperature sensor to make some ML model using that predictive maintenance system for the boiler or something like that, then you can use the flatten. So here you can design your own impulse according to your need. So here I am using the accelerometer for with the multiple axis value to detect the gesture and predict the gesture. So my best model, best impulse is using this one. So I will add it. I will click here add, and then I can add the learning block. For learning block here, what we want to do, there is a different kind of learning block. How you want to train the ML model and use it. So suppose that if we are using the if we want to train a ML model and deploy a ML model for the prediction that will predict out the data from the continuous data, like it will predict the temperature from the continuous temperature that is already coming, and finding the finding the pattern in the temperature that is coming and predict that temperature. Or if you want to predictive maintenance system, then you can use the regression one. If you want to make an anomaly detection system, suppose that we already know this is the correct data, this is the suppose that I am making the engine faulty detection system. So I don't I have trained this model for I have collected the data for correct engine running data, vibration data, and using that, it will if there is a difference in the micro difference in the actual vibration data between the new data, then it will automatically detect the anomaly and predict that out. So you can use the anomaly detection in such case of scenario. But here I am using the classification one, the up gesture, right gesture, right gesture. So I can use the classification one. So based on your choice, how you want to model to be get trained, you can select it from here. So here I am selecting the classification method so that it can classify between the up gesture, right gesture, and left gesture, whatever the gesture. If I want to predict that, I can use a predictive model. So it's on you how you want to design the impulse. So this is why it's called designing the impulse, how you want to train the model and how you want to use the model. It's depend on you. So after that, I click on save impulse. So it will save the whole my impulse design, that this is the how a model need to be trained, and this is what are the model sensor data are XYZ. Okay. After that, we need to go to the spectral features, where the data that we have already collected, it will show you the graph of this. We need to generate the feature from that what are the features of particular data. So here we need to create the features. So it will create the feature from the extract the data and create the feature in numerical values from the data set that we have just collected. Sensor data set of this collected of this IndusBoard coin, of this IndusBoard coin here. Okay, so this IndusBoard coin here. So here it is generating the feature. So after generating the feature, I have already done it earlier. So let's move it to the classifier. So after it done, what you need to go to the move it to the classifier. Okay. So now it had generated the feature. You can see the graph of gesture that feature that you have generated. Now I go to the classifier. Now here I want to, if you want to change the how many cycle your ML model need to be trained with, then you can train according to that, and you can change the different neural network layers if you want to add, or if you want to keep, it's better to keep it default. So I'm going to keep it default. If you want to change it, you can change the neural network layers, how more dense layer you need in your ML model to, and the more denser it will become more complex for the MCU. So let's keep it default setting. And the number of trained cycle, the number of cycle, the more you increase the cycle, the more it will train up the model, but it will take more time to be get trained. So I will keep it default to the 30. So after training that, what I can do, I can test the model using the live classification. So here you can see the TensorFlow Lite is running in the terminal. So TensorFlow Lite model is getting trained. So these kind of MCU, that is present on the IndusBoard run the TensorFlow Lite model too. So TensorFlow Lite is basically made for this kind of MCU to run the ML model on the MCU. So this IndusBoard is going to running the ML model. So isn't it interesting? The whole ML model running at the edge on this device. This is going to be so interesting. So there is a whole AI thing running on very small tiny board. This tiny board is running the ML model and predicting all the data and giving us all those things. So this is just tiny. This is just 3 centimeter board running the ML model. Yeah, so our data is trained now. So now I can test the model using the live classification. So here, as you can see, here is my IndusBoard coin. Here is my IndusBoard coin. IndusBoard coin connected with the laptop. As you can see here, it's connected with the laptop USB, and it is connected to the edge impulse here. And here, what I will do, here it is connected. So when I create a start sampling, it will take the sensor data and then predict out whether it's what the gesture is. So I will test the model here. So let's click on this and then move it to the up, so that it should predict the up gesture. Let's see it's predicting correct or not. So I'm continuously moving the IndusBoard coin towards the up. Sampling fail. Oh, might we got payload is missing. Okay, 1 minute, one more time. Or might be connected in the earlier, no? So it might be creating some kind of difficult. Okay. So it has to detect the model. Otherwise, you can also use the load sample or something where some problem with the connection here. 1 minute. So it's so paired. It's already paired here. 1 minute. Let me connect it again. So it's connected to the data collection thing right now here in the terminal. That's why it is giving the error. So let's load the sample that is already there, and let's classify it. So it's the classification result you can see here. See here. So it's classified as up. That the gesture is up, toward the up. So you can use it with the directly here, or you can use it. You can load the sample from the already trained model to test the model. So after that, our testing is done. Now we go to the model testing. Live classification is done. Now here in the model testing, we will classify all the testing data that is we have just collected earlier in the here in the data acquisition. So we have to classify. We have separated the two different sets of data. One is for the training and one is for the testing. It will automatically separate the data. Otherwise, you can also separate it manually. So I will classify all data, and then after classifying all this data, it will give you the result of what is the accuracy of my ML model. So if accuracy is above 80%, then it is okay. If accuracy is 100%, then it's just the best ML model that you have trained. If accuracy is not up to your mark, they can retrain. You can use the retrain model, and you have to recollect the data, retrain everything, do it again, so that you can make more accurate model. But here we are doing just experiment. So whatever the accuracy come, we will go forward with that and with the deployment. Okay. So let's hope we got the accuracy of this ML model towards the 100%. If the accuracy towards the 100%, then it will go okay. Then it was just wonderful thing. So accuracy is around 81%. Yeah. So our ML model is so accurate. It's only detected two wrong. It detected only two wrong predictions. It done only two wrong prediction, and one is three is uncertain. So that's why its accuracy 81%. So it's a good accuracy number for our ML model. So it will detect this device is going to detect so accurate. Our ML model that we are going to deploy here is so accurate, going to so accurate. So now what we will do, we will click on deployment. So it will ask you where you want to deploy it. So I am going to deploy it to the ESP32, this one. But here let's not use it. Here we can use directly the Arduino library. So here I can select the Arduino library. You can select the Arduino library. So it will make the Arduino library so that you can deploy this ML model on this IndusBoard coin. So here what will click build. So whatever it will do, it will build up the whole ML model and give you the library so that you can use the ML model. Okay. So after that, after clicking the build, it will build up the ML model. So after building up the ML model, it will give you the zip file library like this. Here I have already downloaded it earlier. So here it will give you the zip file like this. Zip file like this. So After getting this zip file downloaded for that is given by the this has a whole file, the example code using which you can use this and use this sensor on the IndusBoard coin, and then it will also give you the what say it will also it also has the whole ML model that we have just trained. Whole thing is in this library. So what we need to do next, what I need to do next is to go to the tools of the Arduino ID, a sketch, and then include add zip file. Here you can see we need to add this library to Arduino ID. So very well, I've downloaded the Arduino ID. Here we will select that zip file, and when I click on open, I have already added, so I'm not going to add it, otherwise click conflict, then it will add. So to test this library whether it's added successfully or not, we could go to the file example, and when you scroll down you will see that library, edge impulse gesture. What is the library name? EIGES. So it will be the in E. It will be in the E. EIGES. Yeah, just in presence. See here. Here our library is included in the Arduino ID. So here we will use the so whatever the ML model you are going to use, you can upload the program according to that. If it's the microphone one, then you can use the microphone one code. If you use the sensor one, then you can use the ESP32 fusion. So here I have modified the code for the gesture detection. Here is the code for that. So what I will do, I have added the library that needed to interface the gestures, the accelerometer on the IndusBoard coin, and then I have include the SDK of edge impulse and AEI classifier and GST just inferencing.h. This is the file. This is header file that will given you by the given by the library that is created using the edge impulse ML model. So after that, we will we have this example code. We have this example code that will test the features of accelerometer X, Y, Z, all those 3 axis data, and it will then it will classify using the ML model that is already written. It will call out the ML model using this. Here is the ML model kept and this at this path, so it will automatically extract out the ML model that is trained on the library. And after that, when I upload this code, now what I'm going to do, here you can modify this code after the classification. Whatever the result support that when there is a left gesture, then display have to turn off, then you can define the function here in the code and modify the code accordingly. But here let's just see the predictions on the serial monitor. So what I will do, I simply upload this code now, upload this code now. So before uploading this code, I will select the CDC, and as it's already earlier it connected to what this that one edge impulse. So what I need to do, I need to unplug it from here, and then I have to close this terminal and click on terminate. So that this board get disconnected with that one. Otherwise it will give you the error because its serial port is already connected to somewhere else. So now when I reconnect this board, it got detected here. Now I enable the CDC and then use the upload mode as the internal USB. Now compile it and upload it. Now what it will do, it will compile the whole ML model and whole code and deploy the whole ML model on this board, and it will run on the edge. It is not connected. As you can see, there is no Wi-Fi configuration, nothing in the code. There is nothing in the code. You can see there is nothing, no Wi-Fi configuration in the code. It's simple raw code. It's the whole ML model running on this tiny, this tiny small, this is small board. The whole this board is running the AI. This board is running the AI in itself. Just 3 centimeter board is running the AI. At the edge, it's not computing anywhere else. It's computing directly on this chip, on this chip. So the code got compiled and it get uploaded. See, it get uploaded. So now I am opening the serial monitor. So here you can see the predictions. Here you can see the prediction. So now I am moving the this one towards the up. So it have to predict that the gesture is up. It go to the 95 or 70 37. You know, the values towards the prediction towards the up got rise. And when I move it towards the left or right, then the value towards the right will get increased. Prediction value result towards the right get increased. Okay. Oh, sorry. 1 minute. Let me open the camera again. Where is the photo booth? Let me open the camera again. So here is the camera opened again. Let it get connected to the. So this is a live cam. So here it is connected with this here, and this is the board. This is the board. Here you can see in the camera. This is the board connected with the PC. With the PC. Okay. And this ML model is running live on this IndusBoard coin. Okay. On this IndusBoard coin. So I am moving this out towards the left and right, and you can see the prediction according. So the whole AI thing, whole ML model, whole the AI, this board is running the AI just tiny 3 centimeters. So this is all the project. So you can modify the project for training different kind of voice recognition thing, like if you want to add the mic or to this IndusBoard coin, and then you can also make a audio classification, the sound detection system, or different kind of ML model directly deploy on this device. And this is how you can do and run a whole AI ML AI on this tiny 3 centimeter device IndusBoard coin. So that's all for today. So we will meet in the next session, and we will try to make some more sensible, some more good AI ML model and some more application based project. Here we have just tested out how to train the ML model and deploy on this IndusBoard coin, and later we will change this code to make some beautiful application using the AI ML model that is running at the edge on this coin. So this is so small coin. This is very small coin, and this is very tough. This is very tough, very small and tough. And it's running at the edge here. Whole edge impulse is running at the edge here on this coin. I can see here the prediction I'm getting. Okay, bye. Thank you, everyone. So you can get whole code and everything on the electronics board. If you have any doubt, you can ask me out. Hello, Vanu sir, can you end it?